So, anion gap acidosis. So, acidosis always causes the bicarbonate to go down. But there's two types of acidosis. There's acidosis with a high anion gap and acidosis with a low anion gap. So, what the heck is an anion gap? So, in reality, if we total all of the positive ions in the blood, and we total all of the negative ions, then that total is the same. There's no difference. These rectangles are the same height. There's no difference in positive and negative, in the number of positives and in the number of negatives, because a solution needs to be electrically neutral. As soon as there's even one or two more positives, then you get like static electricity. So the total number of ions in a solution, positive and negatives, is the same. So anion gap is a kind of like a human artifact. Basically, there's some ions that medical lab tests don't measure, some positive ions that medical lab tests don't measure, and those I labeled here other positive. And there's also negative ions that medical lab tests don't measure, and I labeled those other negative. And as it turns out, the number of negative ions that are not measured is kind of more than the number of positive ions that aren't measured. So what happens is when you take sodium, when you do this weird calculation, sodium, which is this, minus the minus chloride and bicarbonate, then you get this little number here, right here, which is the anion gap. So this minus this gives you this little bit of a difference, and that's called the anion gap. Okay, so that's the definition of anion gap. And it's not a real thing, it's just coming from this kind of artifact that the medical lab tests don't measure certain ions, and that number is different for the positive and negatives. So there's actually no difference between the positive and negative ions, but there are more unmeasured ions. So there's more unmeasured ions, and when we do the above calculation, we get this anion gap number. So what's the point of caring about anion gaps? So the point is that you can divide an acidosis if you know, you get a patient and he's got an acidosis. You can look at the anion gap and say, okay, is it a normal anion gap or is it a high anion gap? And that helps you to kind of know which category of diseases you're talking about. So a normal anion gap, if you think about it, then how do you get a normal anion gap? Well, you can either decrease the sodium while you're decreasing the bicarbonate. Remember, every acidosis starts with decreasing the bicarbonate. So let's start. First, we're going to decrease the bicarbonate. Okay, but we want to keep this anion gap the same. So if we decrease the bicarbonate, you can visualize this this gap growing. Whoa, it just grew. But if we decrease the sodium with it, then that anion gap can stay constant. So we decrease the sodium a bit, and we decrease the bicarbonate by the same amount, and that anion gap doesn't change. So how do we get that? We lose both sodium and bicarbonate, and that happens in diarrhea because that fluid has a lot of sodium and it has a lot of bicarbonate. In Addison's disease, it's kind of an interesting one. So in Addison's disease, there's not enough, it's called aldosterone, because aldosterone is made by the adrenal gland. So there's not enough aldosterone. And what aldosterone does is it helps you get rid of hydrogen ions. So if you can't get rid of hydrogen ions, you retain hydrogen ions. That reacts with bicarbonate. So bicarbonate lowers. That's the first thing. But why do you lose sodium? Well, because aldosterone also helps you save sodium. So you lose sodium in the urine, and you lose bicarbonate. So that's the same net effect. You lose sodium bicarbonate. Short gut is kind of the same thing as diarrhea. You're not able to reabsorb this sodium bicarbonate. And proximal renal tubular acidosis, that's kind of a defect in one of the pumps in the proximal renal tubule in the kidney, and that's the same kind of thing. You're losing the ability to reabsorb sodium, but it's in the kidney this time, and you're losing bicarbonate. So that those renal tubular acidoses, those are kind of pump defects in the kidney, and you can memorize how they exactly work, the exact mechanism, but the important thing to know is that they generally always lead you to a normal gap acidosis. So if you have a normal gap acidosis, you can start to consider those syndromes. And so these other renal tubular acidosis, called the distal renal tubular acidoses, there's two of those, and those have a different mechanism, but it also gives you a normal anion gap. So the mechanism for those is first you lower the bicarb, but then you also increase the chloride. So you lower the bicarb. Oh, it's looking like our anion gap is going to grow, but no, we're going to increase that chloride to fill in that anion gap. So that's normal anion gap acidosis. And then we come to high anion gap acidosis. So high anion gap acidosis, there's actually a mnemonic for it. It's mud piles. And I'm really bad at mnemonics. It's like methanol, uremia, paraldehyde. D is diabetic ketoacidosis. Anyways, so there's all these kind of poisons that get added to the body, and those lead to an acidosis. So basically, pouring acid into the body gives you a high anion gap, because all of these things that you add, salicylates, methanol, diabetic ketoacids, these are all acids. So these are all, they can be visualized as a hydrogen ion and an acid. And so hydrogen ion is positive and a negative ion. So this negative ion is not something that medical tests measure, so it gets added to this category. So the hydrogen ion is going to react with the HCO3, and it's going to give you that acidosis, but then the negative part of it that you add is going to go here, and it's going to be unmeasured. So that's going to increase. So if you can visualize this, you lower the bicarb concentration, and then you increase these unmeasured anions. So that's going to go here, and if you can visualize that, that gap is going to increase, because here's that line. If we increase this thing by giving you, let's talk about like lactic acid. If this is, so the hydrogen ion of lactic acid is going to react and lower that, and then the lactate part of lactic acid is going to go here and lower that line. So then that gap is going to be all the way from there to there. So that's going to give you a high anion gap. So I hope that kind of clarified why normal anion gap acidoses are these conditions, and high anion gap acidoses are these conditions. Thank you.